welcome back to our YouTube channel, Becoming a ROS Developer. My name is Rodrigo, and today we have one of our students, Pruthvi, who has completed the course ROS Basics in 5 days for Python. And at the end of this course, there is a project you can present and implement it on a real robot. So that's what we're going to be seeing here today. So hello, how are you?
Yeah, hello. I'm doing good. How are you doing?
I'm good. I'm excited to see your presentation. So please, whenever you want, start sharing your
Okay.
screen and show us how you've solved your project.
Yeah. Um, Hope my screen's visible right now.
Great. Yes, we can see your screen.
Okay. Okay. So I'm just connecting to the robot with the lab. And, uh,
Okay.
mhm. Okay. Yeah, I'm just checking if I'm connected. Um, yeah, I'm connected. Okay. So we'll be doing the wall following.
What is that? We don't know. If you could provide more context.
Okay, yeah. Um, so we have so the project that requires us to complete this course is basically a wall following robot. So here we have three main functions that the robot will be doing for us. So first, the robot will find the closest wall at a minimum distance, which I will talk about in detail a little bit later. And the next thing we'll be doing is the wall following. So what we do is the robot will be following the wall, and it'll complete a course of one lap, and it'll come to a halt. And for this to work, we taken the help of laser readings to get the distance from the wall, and to identify and to find the wall as such. And the next thing is we have three main servers that will help us accomplish this. The first is the service server, which helps in finding the wall. And then we also have the main node, and we also have the action server, which will ultimately control the whole function. Yeah, so that's basically what we'll be doing here.
Great.
Yeah. So let's just get in. Oops. Mm,
It's packages.
Yeah. Oh, so I just missed. Yep. And okay. Let me just get the bot first on the screen.
Mm-hmm.
Um, okay. So here we can see the bot first finding the closest wall,
Mm-hmm.
and then it distances itself to the minimum distance from the wall, and then here we can see the bot then navigates across the map to go to complete the lap. So here we can see that the bot. Uh, okay, I think we should have increased the speed of the bot a little bit, but
It's all right.
okay.
I mean, it's going quite
Yeah.
fast actually.
Okay. And you can and we can see that it tries to follow the closest wall. Um, uh, if you give it a minute, like it should, yeah, identify the walls. Yes.
All right. So right about now, it's completing a lap. No.
Yep. It completes the lap, and uh, it, okay. So uh, we can see that it hasn't. It's still. The thing is, it's taking in those obstacles to be as walls as well, and it just so it missed its initial position, and
Okay.
yeah. Yeah, think it just. Oh yeah. Um, yeah. So here we see the a bot is able to identify the minimum distance from the wall, which is preset, and it's able to follow the wall. Um, and once it's completed its trajectory, it comes to the halt.
Okay. And in this case, it did it. So
Yeah.
what uh,
I
what is supposed to
uh,
happen once you reach that position?
yeah. It just comes to a halt, and that
Mm-hmm.
should be it.
Great.
Yeah.
Okay. Uh, do you mind if I actually ask you some questions,
Yeah.
Prithvi? Yeah.
Yeah.
So,
Please. Please.
um, so the first one is, how does it know when it has completed a lap?
So the thing is, first we I've set an initial position as its in terms of coordinates to give it but the thing is it didn't for some reason it missed that point, and it just kept moving because it took in those objects as I mean obstacles as a wall, I guess. I mean, that's what I believe it did. Um, but or maybe um the stop the code to end the action didn't go through. That could be one of the reasons. So these are the reasons I believe uh
Well,
for
my
it to not
question though
work.
was, how does it know when it has
Hmm.
completed a lap? You mentioned an initial position.
Yeah.
So how does it
So
know?
actually
What is
it
the answer?
so the thing I did was it was based on runtime and the speed. So I went to the simple terms. So actually,
That's okay. You can just.
during
That's
working,
fine.
yeah.
So what was it? I just want to know
No, the thing is,
the answer.
yeah, the thing is, what I did was when I was doing this thing, I thought like maybe when I run it and based on the time. I estimated like after this time, if we make it, if we stop if we provide the stop command and then it stops, but then for some reason it didn't work right now. Um,
So you were setting it after a certain time,
yeah, exactly.
and it didn't happen.
Yeah.
Okay. So all right, okay. So we might investigate. Why do you think it didn't happen?
Um,
Could you maybe
Probably
show
because
us the code, and maybe we can
yeah,
take a look together?
yeah. Mhm. And follower, it's some service has finished. Node is completed. Okay. And then this. Okay, this is all the distance and position. Hmm. Executive shutdown. Yeah. Normal picture. Okay, this just the
So where do you send that zero value of velocity,
value.
let's say? There must be a publishing
Yeah.
or a stop or something.
I have the speed and okay. Yeah. Self dot linear is here. This is just the normal moment timer. Okay, for some reason it's not here. Even my variables which I set to 0 and
So what is that motion to center uh, method?
yeah. So actually, when in the beginning when you find the wall, we need to uh, after we find the distance from the wall, we have to align it in a position where it follows it and not it doesn't direct towards or away from the wall. So in order to position it at the exact distance like from the wall with that specific distance which is predetermined which is 0.25, we use this motion to center.
But that's not part of the service, right?
No, it's not. No,
Okay.
it's part of the action.
No, I mean it's in your wall following.
M- Wall following, yeah, but it's not part of the service server, yeah.
Neither it is of the action.
Action. Okay. I believe it's part of it's not part of the service, that is for sure. But so in the beginning, when we start finding the distance of the bot from the wall, we can see that it takes time to adjust itself to centralize itself to start its movement. So I think that is where I've used this um, motion to center uh, to get the fixed position of the fixed initial position of the bot. Um, and it is also to keep this minimal distance from the wall.
Okay, so then the motion
Mhm.
one is what? If the motion to center is the one to
Uh-huh.
keep the minimum distance from the wall, which was 25 centimeters,
Yeah.
then what is this motion method?
Okay, so once we find the wall, we send in the uh, uh, so it has to start following the wall, right? That is the
Yeah.
function of the bot. So once we find the wall, we start following it throughout the in a linear fashion. That is what we do with the motion, and we also have uh, if there is a wall in front, we uh, turn left or right to avoid it. So basically, but here in the track, we only turn left for the wall if there's a wall in front, because there's always a wall in the right. So that is why we use this motion to accomplish that.
All right. So at the end, we do not know. Here, look at it. I just found it for you. The message linear zero,
Yeah, linear.
message
Yeah, yeah.
angular
Oh, yeah,
zero.
yeah. That's true. No,
So
this one is if we don't find a wall. So that is when it comes to a halt. But here, yeah, I think that is where we went wrong. Probably it just kept finding the wall and it just kept moving.
Okay, I don't understand because this is the wall following node. So whatever you
Yeah.
put in your service should be in
Hmm.
a service server, right?
Yeah.
So you
Yeah.
have another program in there called Wall Finder. I'm pretty
Yep.
sure. Yeah. So what does this do? This behavior is does the
So this is the laser. It does the laser scan in order to find the wall. So
so it does
uh,
not know it does no movement.
no, it does no movement.
Ah, I see. All right.
Yeah.
So, but in here, can we find where you actually create the service server?
I'm sorry. I think
So
your
to
voice is not
find
clear.
the callback that is executing. So in here you have a
Mhm.
place where
We
you
have the find wall callback. Yeah.
no, I mean the place where you create the service server.
For some reason your voice is not
It's at
clear.
the beginning. It must be by the beginning. There's an initializing of a server.
What? Yeah, the wall finder server. Yeah.
I mean the object create service right there. I see it, line 18,
Yeah.
and it has
And
a callback that gets executed when you call that service, correct?
yeah. Yes.
And that's what is it?
I know. I don't understand the question though.
What is the
This is fine.
callback function that gets executed when you call the service, the ROS2 service? You know, when you do ROS2 service call, that
Yeah.
you must be calling at some point. Um,
Yes.
wh- which
So
which callback function gets executed?
so we have the find wall callback that
Exactly.
gets
So let's
sorry.
let's go towards that find wall callback.
Okay.
Um, so
Yeah.
so in here, what do we see actually? So there's a contradiction from what you told me. That you said that the service is for the LiDAR, correct? That's what you said?
For the what?
For the LiDAR. You said this service was to find the closest wall with the LiDAR. And
No, it finds the wall using the laser. Yeah.
and then I asked if
Uh-huh.
this included no movement. This service had nothing to do with the movement, and we can
Movement.
see it here
Yeah.
that it does some movement. So
Uh,
definitely,
it's,
um, I have a couple of those comments about that. So the main one is the inability of the robot to stop, uh,
okay.
since obviously based on what you've showed me, it's not going to. So
Yeah.
the main thing would be to implement what you said about either time or stopping it after the
When it find
odometry the, that
when it
you're
doesn't find a wall
hmm
to
that
follow. Yeah.
you're doing. So uh, and last, for example, I want to show you this. If you go to the action server that you created,
Which part of the action server do you want me to go?
I mean the whole thing, like the action server, you know, the one that record. So there's the service server that does what? The finding of the
Finds
wall.
the wall
Yeah.
and then
And then the
it
main
it
node is the one
minimum
that
this is
follows it. So the
yeah
action server must be uh, the
to control the movement.
no no the action server in part 3 of the project
Hmm.
was to record the odometry, correct?
Oh yeah, yeah. Oh okay. Yeah, I got it.
So here is your action server. So
Mhm.
at this point, you subscribe to the odometry, right? And you are
Yeah.
actually publishing it. I saw it on the
Output from on the
yeah. So it must be here somewhere where you do
yeah
the output and you're inputting the
yeah
actual number.
terminal.
So in there, you can actually do this check and run it once. After it's done that amount of odometry, here
Okay.
you're adding it up. You can
Mhm.
stop it. So that's
Oh
one
okay.
thing. And another thing that I was just to comment to check is the actually I noticed that it was 25 centimeters to the right side of the closest wall, but it
Yeah.
wasn't. It was getting way closer in the
Mm-hmm.
demo
In the
we
demo.
saw,
Yeah.
and it was getting away a lot more too. So
Mm-hmm.
it would be interesting to know the reason why those are
Okay.
happening. But yeah, um, those are all the comments I have, Prithvi. So thank you very
Okay.
much for your time and for
Thank,
showing us your presentation.
thank you. Yeah.
All right. So let me just switch back here to myself. And yes, this is what you can do in order to obtain one of our certificates. We encourage people to present their projects once they have finished their courses and present them in order to showcase what you've learned throughout our course and to get one of our certificates. Our certificates mean a lot to us, so we must know that people are actually taking something out of it, and that's why we require this presentation. So I encourage everyone to do the same here, and we'll see you guys next time for our next video, guys. All right, bye-bye.